Question 1. So let L be the tangent to the curve y equals x times e to the power of 2x at the point 1 e squared. And we want to find the coordinates of the point where L meets the x-axis. So one way we could go about doing this is we could differentiate that function and then work out the equation of the line of the tangent to the curve at the point 1 e squared and then go from there. However, another way we could do it is we can take advantage of our graphing calculator. So that's what we're going to do in this video. We're going to use our graphing calculator to solve this problem. So if I just bring up our calculator. Okay, so the first thing we want to do is open a new document with a graph on it. So to do that, we just click down here for graph and just make sure we're opening a document and not the scratch pad up here. Because if we open a graph with the scratch pad, then we're going to lose some of the features that we need. So we'll open our graphing document. Okay, and it just says doc up there, not scratch pad. So now we just plug in our function. So that is x times e to the power of 2 times x. Okay, so there's our function there. Now I want to plot this point 1 e squared. So to do that, what I'm first going to do is just plot a point anywhere on the graph. So to do that, if we go menu, and then down to geometry, points and lines, and then number 1 here, point. And then I'll just find some point on the graph. I'll just pick anywhere, say here. Now that is obviously not the point 1 e squared, so I want to change our x coordinate to the number 1. So we just click up here and then just highlight over it so we get that text showing up, and then just double click, and then we can plug in our x coordinate. Okay, now we can't see that point which I've put in with the x coordinate of 1, and it automatically finds the y coordinate. So we've got 1 e squared plotted, but it's off the end of the graph here because my y-axis is only going up to 6.67. So if we just zoom out a little bit, then we can see our point there, 7.39. And 7.39 is approximately e squared. So the graph is just giving us approximate values, because obviously 7.39 is not the exact value of e squared. So now we can just make this a little bit nicer to look at, because we've got all this empty space. So it's going to become much easier when we start plotting in the tangent line and things, if our graph is nice and clear. So if we just come back to menu, go to the window zoom, and then window settings. So I've got x as negative 20 at the moment. So if we change that to, say, about negative 2.5, and then for our x max, we'll change that to positive 2.5, then we get a much clearer view of what's going on in this graph. Okay, so now I want to plot the tangent line at that point 1 e squared. So to do that, we just get back to menu, geometry, points and lines, and then number 8, the tangent. And I want to plot it right at that point 1 e squared. So I just keep coming up till I hit where it says point on, and then just click. And there's our tangent line there. So if I just click up here, then I can actually extend this line down through the x-axis. So we can see where that tangent line cuts the x-axis. And again, if we just hover over here, it says text, I can then move it about. And that's the equation of our tangent line. Y equals 22.17x minus 14.78. So they're just approximate values to 2 decimal places there. Okay, so what we want to do now is we want to find out where that tangent line cuts the x-axis. So to do that, we will plot that line. So new graph function, and we'll plug in the equation of our tangent line, which is 22.17 times x minus 14.78. Okay, so there it is in red. So that's our line L, which is tangent to the curve of our function at the point 1 e squared. So now we just need to find out where it crosses the x-axis. So just go menu, analyze graph, find the 0, and just click on the graph that we want to find the 0 of, and somewhere to the left, to the right, and there's our coordinate there. X is 0.667 and y is 0. So that's actually our answer. So that is the coordinates of where that line L meets the x-axis. So what we want to do now is show our working so we can get full marks for this question. So we can write down the equation of our tangent line, which is y equals 22.17x minus 14.78. So there's our equation of the tangent line, and I've just put the dots there just to show that they are approximate values that are given on our graph. Okay, and we know that that equation of the tangent line, or that tangent line there, that meets the x-axis when y is equal to 0. So that implies when y is equal to 0, that x is equal to 0.667. So therefore, our coordinates of where the point L meets the x-axis are 0.667 and 0. Okay, and that is question 1.